We've been learning about combining functions. Yesterday we talked about adding functions, subtracting, multiplying, and dividing. So I want to ask a couple questions. If I had f of x and I added that to g of x, what do we call that new function? F plus g of x. So f plus g of x. My question is f plus g of x the same thing as g plus f of x? So yes, why is that the case? They're both positive? Yes? We'll talk about that in a second. So these are exactly the same thing. Why is that? Right, the order of addition doesn't matter. Up on the wall, numbers are commutative, not commutative. That's what everybody tends to say. They're not part of a commune. Okay, they commute, they move. So f is just made up of numbers. G is just made up of numbers. If you take numbers and add them to other numbers, it doesn't matter what order you add them in. Is f minus g of x the same thing as g minus f of x? No, because numbers do not commute with subtraction. It's only true if they're the same. If they're both 5, then you get 0 in both cases. So subtraction does not commute. Does multiplication commute? So there's a question about multiplication. So let's just do g of x times f of x, which is the same thing as g times f of x. And I'll show you what that looks like here in a second. Is that the same thing as fg of x? Yes. And whether or not you put that dot there doesn't make a difference. So if my f of x was 2x plus 1, and my g of x was x plus 2, how would I figure out f times g of x? You just multiply these together, and you distribute. Does that make sense? Okay, and does it matter if I do 2x plus 1 times x plus 2, or if I flip it around and do x plus 2 times 2x plus 1? No, doesn't matter. What about division? Is f over g of x the same thing as g over f of x? Certainly not. Division does not commute. Now, as far as you know, these are the only operations in existence. You might say exponents are another operation, but they're just a fancy form of multiplication. You might say that square roots and third roots and all those other roots are also new operations. But square roots are just fancy exponents, which are fancy multiplication. So technically, yeah, they're second cousins. So technically, this is it. But last year, if you were in my class, we learned about function composition. So with numbers, you have addition, subtraction, multiplication, sometimes listed as a dot, and division. There are no other operations. Okay, you could create your own operation if you wanted. Like, you could say like 1 triangle 2 is 8, and then define it yourself. And sometimes that's useful in math, but we're not going to do it today. We are now going to review the symbol circle, which is kind of like addition, kind of like multiplication, and it's called composition. Okay? So, let's define two functions. F of x equals 2x, let's just do x minus 5. And g of x is x squared minus x. Okay? So let's talk about how these functions compose. So let's list some of the things that function f does. If I plug 1 into f, what do I get out? -4. If If I plug 6 in, what do I get out? 1. If I plug in 14, then I get 9. Okay? What? Oh. Unless you're Hannah, then it's not 9, it's something else. Hello, Dave Bird. I'm speaking to Dave Bird now. He's in my 5th period class. He asked me the other day, who's Hannah, and how come you always say her name in those videos? So, he wondered who you were. So, Dave, if you're listening, Hannah just turned bright red. Okay, so he didn't know which Hannah it was. So let's look at function g. Let's take the range of f and plug those numbers into g. So what does g do to negative 4? Well, negative 4 squared is 16 minus negative 4 is 20. So g takes negative 4 and turns it into a 20. What does g do to 1? 1 squared is 1, minus 1 is 0. What does it do to 9? 81 minus 9, don't let Hannah do this, 72. Okay? So how do we write this? Well, if we look at the system, here are my x values. I'm taking my x values, plugging them into f, and creating f of x values. Does everybody see that? 1 is an x. I plug x into f, and I create a new number whose name is f of x. In fact, this is f of 1. So my x columns turn into my f of x columns. Then I take my f of x's, and I plug them inside of g, and that creates g of, well, they're not x's, right? It's g of f of x. And that is the composition. G of f of x means plug numbers into f. Once you figure out what those numbers become inside of f, take those answers, plug them into g, and you create a new function that is g of f of x. Well, what is its name? Yeah, so in order to write its name, remember how we did f of x plus g of x? And its name was f plus g of x. So we're going to use this circle to create its name. But it's always backwards from the way that you want to do it. So its name is g composed with f of x. Okay? Now you might look at that and say, okay, take g and plug it into f, but that's not the way it works. Composition always works from the inside out. So if you write it in the first form, it's really simple. Plug x into f, figure out what you get, plug f into g, and that's the new function. But when it's written in composition form, it's not as obvious that you go backwards. You always start with the last function and work your way towards the first one. Well, so why would you prefer this one? The reason is this is not a name. That is a set of instructions on how to create a function. This actually gives the function's name. And so sometimes you need the function's name. So you can say plug, I'll show you here in a second. So we have figured out what 3 of these points do. If you take 1 and plug it into f, you get negative 4. Plug that into g, and you get 20. Same thing with 6 to 1, 1 to 0, 14 to 9, and 9 to 72. What if I want to do that all in one step? I need to plug the function into the other function. So I need to take f of x, this, and plug it in to g of x. You don't multiply it in, you replace the x's with the other function. So g of x is something to the second minus that same something. X squared minus x. But when I plug in f instead of x, I'm going to use x minus 5. Does that make sense? Now this is a pretty nasty one. A lot of them are easier than this. So we'll do a hard one, then we'll do a really easy one. So we're really good at multiplying these out. X squared minus 10x plus 25 minus x plus 5. So that's going to equal x squared minus 11x plus 30. We have negative 5, right. Well, this function, that function is created by plugging the function f into the function g, and that function's name is g of f. And g of f bridges the gap from the beginning of f to the end of g. So if I plug 1 into g of f, I should get 20 if I did everything correctly. So let's try it. Plug in 1. 1 squared is 1, minus 11 is negative 10, plus 30 is 20. If I plug in 6, I should get 0. 36 minus 66 is negative 30, plus 30 is 0. Everybody understand that? Okay. If I plug in 14, I should get out 72. Oh boy. 14 squared is 196 minus 121 plus 33, 154 plus 30. I did it right, 72. Something like that. Okay, so now my question is, let's go get rid of a lot of this stuff. Okay, so I've created g of f of x. Is that the same thing as f of g of x? Does composition commute? Well, let's try it. Let's plug g of x in for f. That's super easy. What do you get when you plug g into f? X squared minus x minus 5. That's nothing like g of f. Okay, so let's suppose I'm given 3 functions. F of x equals 2x plus 1. Yeah. G of x equals x minus 4. And h of x equals x squared. How would I calculate this? I'm going to take the information of g of x, this stuff, and I'm going to put it where the x is in function f. So f is 2 times x plus 1, but instead of x, I'm going to write x minus 4. So I get 2x minus 8 plus 1 is minus 7. Well, I wasn't required to use h of x. So what if I said, let's do h of g of x. How do I figure out that one? Plug g into h. So it's going to be x minus 4 squared, which we know is x squared minus 8 plus 16. Okay? What if I had f composed with g composed with h of x? So by plugging h into g, I get, so if I stick this in there, it's just x squared minus 4. And then I'm going to put x squared minus 4 in for f. And f is 2x plus 1. So I put this stuff in here, x squared minus 4, and we'll get 2x squared minus 7. Okay? And you can even do f of x. What would that look like? You just put 2x plus 1 into the x for 2x plus 1. So I'm going to put this in here. So 2 times something plus 1, and that something is itself 2x plus 1. So 4x plus 2 plus 1 is 4x plus 3. Now there's a lot more going on with composition than you know so far. On this worksheet, you just need to do the first 2 pages. And I think near the end of the second page, you start dealing with, yeah, the last 2 on the first page. One is addition and one is multiply. So most everything you do today is going to be composition. This assignment was 100 problems. It was 10 pages. And I threw out 5 of the pages. So you'll notice we skipped from 34 up to 47. We skipped from 58 to 71, and we stop at 82. So I threw out 5 of the pages. So here are the answers. Yeah, just do the first 2 pages. So the answers are right here. And just remember that once you finish page 2, you have to skip ahead a little bit to get the correct answer. So just work on those 2 pages today. I just had